Hi, we have AP Physics 1 Past Paper 2024. We are discussing the section Free Response Question. In this section, question number 4 carry the 7 points. A simple pendulum consists of a small sphere that hangs from the string with the negligible mass. As shown in a fig, the top end of the string is fixed. The sphere is pulled to the point A so that string makes a small angle theta with the vertical as shown. This is the small angle theta. The sphere is then released from the rest, swing through the lowest point at B, mean it moves in this direction toward the B. The work done on a sphere by Earth between the points A and B is WE. The pendulum is then taken to the planet X. The mass of the planet X is same as the mass of the Earth, but the radius of the planet X is greater than the radius of the Earth. So, the sphere is again brought to the point A, displaced from the vertical, released from the rest, swing through its lowest point at B. Work done on a sphere by the planet X between the A and B is Wx. Now the first question is justify why Wx is less than We. So we have the force F is equal to Gmm over R square. Now we can place the value of force that is equal to mg. So from m can be cancelled here. We have the value of Gm over R square. So in this case, the masses of the both planets are the same. So me or mx is equal capital G is also gravitational constant is equal, but the radius are different as the Rx planet of x is greater, so Rx is greater, value of Gx is less. So that's the conclusion. Gx is less than from Ge. Work done by the planet gravity on a sphere from point A to point B is equal to the change in gravitational potential energy. Work energy theorem. So we can say W is equal to mg delta H. In this scenario, masses are same, delta H is same, only variation is in the G. So since the planet X has a weak gravitational pull as we have described here, due to larger radius, the product of mgx delta H will be smaller than mge delta H. So in this case, we can describe here that the work done by the planet X is less than the work done by the Earth. Now the new case is the new pendulum is made hanging the same small sphere from the different string with the negligible mass. The new string is slightly elastic and the length of the string may increase or decrease depending upon the tension applied on the string. On Earth, where the sphere is again displaced theta from the vertical and released from the rest, the new pendulum oscillates with the period Te. The new pendulum is then taken to the different planet, let's say planet Y. The radius of the planet Y is same as the radius of the Earth, but the mass of the planet Y is larger than the mass of the mass of the Earth. On planet Y, where the sphere is again displaced from the vertical and released from the rest, the new pendulum oscillates with the period Ty. Now the question is in clear coherent paragraph length response that may contain drawing show explain how Ty could be larger than Te, how it could be smaller than Te. Now we have to come to know that period of simple pendulum T is equal to 2 pi square root L over G. It depends upon the length and the G, inversely proportional to the G and directly proportional to the square root of the length. So from here we can conclude force of the gravity is equal to Gmm over R. From here we can cancel M, value of G is equal to Gm over R square. In this scenario, radius are same but masses are different. Planet Y have the greater mass as compared to the Earth. So we can conclude the gravitational pull or gravitational acceleration is greater on the Y planet as compared to the Earth. So in that scenario, if inversely proportional is seen from here, we can say when the value of gy is greater, the time period for in this scenario is less. But we have to still see in the length scenario. What happens in the length? It is an elastic string. Length is not constant. It stretches under the higher tension and less under the lower tension. Tension depends upon the weight of the sphere and the swinging motion. Now, the tension varies during the swing. It is minimum near the highest point because in this scenario, tension is here. Tension is balanced by mg cos of theta, while tension is maximum at the bottom WB, where is equal to mg. This causes the string to be shortest near the A and longest at the B because the tension is greater at this point and smallest is at this point, as we have concluded. So elastic length is less. We can say shortest at the point A and the longest at the point B. Now the period of the pendulum is t is equal to 2 pi square root L over G. Time period is directly proportional to the length. When the length is greater, it's mean it is the point B when the longest length it has. Now, the two scenario he asks when the Ty could be larger than Te. If the elasticity is more significant, greater length variation on a Y compared to the Earth, the potentially overcompensating the effect of larger G. So we can conclude the Y when the in Y planet when the length or we can say the tension is higher, so length is higher, so time period could be higher as compared to compensating the value of Gy. We can say the time period could be larger as compared to Te. And Ty could be smaller because the string is elasticity is minimum, length variation is small on Y as compared to Y, larger Gy dominant. So Gy could be greater in this scenario, so Ty would be less. So in this case, Ty is less than Te. So both scenario, if the tension dominant or elasticity dominant, in this scenario, Ty could be greater than Te, or if the gravitational pull dominant, then the Ty could be smaller than Te. That's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share it with your friends. Okay, take care.